Look at that. Hey everyone, today I'm going to be showing you the world's fastest heat conducting material. So first let me show you how fast this thing actually conducts heat. It's pretty amazing. It's almost instantaneous. Okay, so now we're going to try to actually see this heat transfer. So I'll put my copper pipe right here, and then I'll put my heat pipe on the other side here. So when this stuff gets cold, it turns black. Okay, so what I'm going to do is I'm going to set ice on the heat pipe and the copper pipe, and we're going to see how fast the heat gets transferred from the pipe to the ice. Okay, 3, 2, 1. Whoa, it just instantly turned it black here. And now you can see it slowly moving up the copper pipe. That is awesome. Okay, 3, 2, 1. Look how fast this one turned black. The heat pipe was almost instant. So what's really neat with this is by just using the heat in your hand, you can actually cut through ice like it's a razor blade. Look at that. So this is just using my own body heat to cut through this. This isn't heated at all. Look at that. So copper can transfer heat at around 0.4 kilowatts per meter Kelvin, and this heat pipe can transfer at 100 kilowatts per meter Kelvin. So what's a little bit scary about this is, as I'm cutting it, it's going to generate heat, but it conducts heat so fast that it'll probably burn me, so I'm going to wear some gloves while I hold this. Okay, so inside of here, it just looks like a hollow copper pipe. But let's look closer and see what we can see in here. Okay, so I've split open the end and bent it down here. So you can see the inside of it. It's not just like a smooth copper pipe inside of it, but it's actually really spongy. So the sides of the wall here are almost like it's a sponge. And the reason that that's in there, because inside of this, there is actually a little bit of water. And usually what they'll do is they'll get a regular copper pipe and they'll fill it with a little bit of water, and then they'll let that water boil, and then they'll seal off both ends of the pipe so that all that's left in there once it's sealed off and cools down is a tiny little bit of pure water in a vacuum. And so there's a really low pressure in there because the water that was hot vapor condenses down once it cools down, but the ends are sealed, and so basically you just get a drop in pressure and a tiny little bit of condensed water. And the spongy inside of the pipe is so that the water can get wicked up onto the sides of all of the pipes. So then how this heat pipe actually works is it's made of copper, and so you still get the copper conduction itself, but the magic comes from the water vapor inside of it. So the tube starts off at a very low pressure, but as you heat up one end of it, the water that is at that end of the pipe heats up. And when it heats up, it vaporizes. And as it vaporizes, the pressure increases. And if the other end is colder, then that means that there's a pressure force driving that water vapor to the other side. But now the other side is colder, and so the water vapor now condenses. And so basically you get this fast push of water vapor to the other side, and then it condenses. And so it takes heat from this side and quickly pushes it to the other side. These are used in a lot of applications, including inside of computers. When you need to transfer a lot of heat quickly, these heat pipes are unmatchable with any other standard metal. And thanks for watching, and I'll see you next time.